Alright, welcome to Doozer shop. Got the drill press, the Cleereman drill press, the mighty Cleereman, complete. Pretty much complete. I'm standing way back to get you a big shot of this thing. It's so huge. The ceiling's 9 feet, and that thing's about 8 feet. It could use a little taller with the spindle. But let me take you and show you a little bit of the details that I've been doing to it. It's probably my last video in the series for this machine. And I'm probably not going to go super mega clean on it, because it's been not outside. I think it's been in covered storage, but you know, barely covered storage. The table works nice and smooth. You gotta unlock the table. The lock works pretty well. That's at the top. Okay, so that works pretty good. And that's the stop. The table was pretty much all the way up. Let me show you this real quick. So that's the forward reverse control. And you know, the lever used to come straight down and it ended basically right there, almost touching the depth stop. So what I did, and I'm fighting for space here. Let me get it straight on. All right. It's 3/8 fine thread in the you know, this chunky piece here. So I had a 3/8 fine thread by 6-inch Allen screw. And I had a piece of pipe here, which is 3/8 inside, 5/8 outside, thick wall tubing. And what I did is I TIG welded on another piece of 5/8 solid. And you know, my welds are just amateur, but you know, TIG has always got good penetration, and I haven't done it in a little bit. But anyway, so I tapped that piece, you know, 3/8 24. And I got my rod coming, you know, pretty much straight out horizontally. And so what that allows me to do is it just has the controls at a nice, you know, these are kind of leveled off, that's leveled off. I got 6 inches, you know, in between, you know, for grip and whatever. Let me turn it on. So the way I figured it, if you're going to power tap with this thing, forward, going down and screwing in, I decided to make forward down. Alright. And of course reverse is up. And that would, you know, unwind the tap for power tapping. Pressure, which is nice. It's a really nice. I'm quite happy with that. So you hear a little gear noise. Believe me, that's nothing. It was twice as loud before I got the gear mesh set properly, or the way I think it should be done. So that worked out good. Worked out well. This is the power down feed stop. It's pretty neat. You can set, oh, how does this work? There. Why isn't that working? Oh, it's all the way up. So let me, no, even with it, how does that work? Even with it's up, it should move, right? So, okay, so let's see. think it was back around the wrong way. So there's 0. Let's say you want to do, from where you're at with the coil, you want to go 1 inch deeper. So you'll use the wing nut here and lock it down. What a nice wing nut. They used to make quality stuff, you know, back in the day. Design, now they don't have anything good, just garden variety wing nuts. So anyways, it'll do a 1 inch down feed. Let me turn it on. And then you pull the bull horns out, and they're down feeds. Maybe I did it backwards. Oh no. There, 0. They clicked off. And there they clicked off. So, let's see. Up. The down feed, it should stop around 12 o'clock. Okay. So that's a neat feature. I'm going to loosen it up. You know, let me show you the motor. I was showing you the adjusters. So that's what them are, right? Well, the motor is bolted from the top. And then you got these threaded adjusters that go through the cast plate. And there's like some castellated slots for turning with a little Tommy bar or something or other. And then your seal, that's your seal plate. Those bolts with the washers, there's holes in there with a lot of clearance, so no matter what your motor alignment, you know, your seal plate can conform to whatever that is, and then you just snug the bolts up at the last step. So that's cool. Let's see. You got wires from the motor, and the other one you kind of see picking up is the switch. And let me go around, show you the circuit box. So there's the motor on this side, same deal. Let's see here, turn it off, be safe, Doozer. Alright, ba-da-da-da-da-da. Alright, so you got control transformer, main on-off switch, and some reversing contactors for and overloads and everything. One thing I want to show you guys, and it's either, see, it says 460 volts, 60 hertz, you know, whatever. Same thing on this one. It's upside down though, 460 volts. Those are the coils. And the red wires are the coil feeds. So this machine's got 460 volt coils, and I just got, you know, 230 volts, 240 volts three-phase in the shop. So what I did real quick, control transformer. The top you can put in, you know, 240 or 480, and then the bottom, typically you get, you know, 120 volts out for your coils. So your coils and your switches are 120 volts, or sometimes they're 24 volts, depending on how safe you want to be. But what I did here is the two terminals on the left, you know, it's on top are the two primary windings, and you can see it's a, you know, 240 volt on the left and a 240 volt on the right, and you put them in series for 480 volts, and you put them in parallel for 240 volts, and you can see the jumpers, and they list the whole, you know, how to do it. But I didn't do anything like that. What I did is I powered the one, oops. So the left two terminals, you got a common, the left two I'm putting in 240 volts. And the extreme, you know, the left and the extreme right is 480 volts. So basically, I'm charging one coil with 240, and it's going through both of them and putting out 480. So that's pretty easy. So my switches inside the machine are 480, and so are the coils and the contactors. These are GE, just happen to be. So that's that. All right. But overall, man, I did a ton of work on this thing. I've been checking spindle run out, man. This thing has, it's not much. Let's check it. Put the switch hands here. Now, mind you, this is with a drill chuck, and let's see here. Hold on. It's 2 thou. And you know, my chuck is whooped, right? It's just kind of a chuck I had used, and I was spinning it on the taper to see if I could get the least run out, and the jaws are kind of not great. But in the spindle bore, you know, it's like half a thou. So anyways, I just did so much work to this thing. I mean, you talk about cleaning everything, so I won't touch too much on this, but you got to clean this dovetail surface here, and you know, of course, below the table, and then you got to clean this one here, and you know, wire brush it, and then scrape the rust off with a razor blade, wire brush it, stone it, and you got to do that one, and then, you know, I had the gib out, this gib strip. I took that out and I cleaned it, wire wheeled it, stoned it. And the same with this whole up and down sliding head. Had a gib in it, took that off, cleaned it, and then, you know, cleaned and stoned these surfaces, the fronts and the back behind the dovetail, and then, you know, below. Here you go. Just the same thing, right? The front surface and behind, and you know, I don't got them clean as clean could be, but all these gear teeth were just packed full of grease and mud, and you know, and then, you know, same for that. So the table and the head go up and down like a dream. There's a counterweight in the column. They call this a 25-inch drill press because it's got 12.5 inches, you know, from the center of the chuck to the column is 12.5. But I just, you know, a lot of work went into it, changing that motor out. I still got the hook in the ceiling. It's a new gauge. Ow, I'm walking into stuff. And man, look at the spindle spline. It's 1 5/8 spindle spline. Man, this thing is just stout. 12 inches of stroke with this guy. 12 inches of travel. And let's see here. 50, 62, 85, up to 550, 775, and 1,000. I got to check with a tachometer. I don't know if that 1,000 is correct. I think they put a 1200 RPM motor on it for 1000 and an 1800 RPM motor on for 1500. So I'm gonna check in a little bit here. Feed in thousands per rev, 5 thou, 7 thou, 9 thou, all the way up to 45, which is really fast. There's a worm gear in here, so I need to get 2 quarts of Mobile SHC 634, which is synthetic worm gear grease. SHC 634 is phenomenal worm oil. The top is supposed to take ISO 68 weight oil, and seeing as the gears are just a little bit loud still, you can put the oil in there, and it just gives a cast iron cover. It just sits in there. That little open. There you go. And there's your drain. But yeah, ISO 68 oil. I'm thinking I'm going to get some Vactra Waylube, because that's ISO 68. And instead of getting Vactra number 2, I might get Vactra number 3, which is ISO 110, or maybe I can get 4, which is really heavy. It's ISO 220. And that'll climb up and quiet the gears maybe. But anyhow, just a ton of work. My hands and my arms have been getting dirty up to my elbows every time I work on this thing. Like I said, probably not going to paint anything. I don't have coolant in my shop, but if anything gets coolant, this might, because drilling creates a tremendous amount of heat. It really does. But I wanted a usable machine, and this thing is 100% usable. And you know, I got a drill bit collection to use, with Morris tapered shanks, and that's gonna just plugged right in there. I decided not to VFD this thing. Anyhow, this is my project today, was the arm. Oh, and if you're wondering, why didn't I just bend the rod? In the factory ones, some of them are bent. But then to unscrew it, you gotta pull that taper pin, and there's a ball and a spring in there for the detents, and you gotta take this off. And yeah, I know you're not gonna take it on and off. But I just, I wanted to do this because it looks cool, and it kind of satisfies my mechanical, my brain, because it's take apart, able to be taken apart. All right, I'm rambling. Thanks for checking out my video series on the mighty Cleereman, and I got a name tag I got to put back on it. But yeah, appreciate you hanging out. Till next time, Doozer's Shop.